Good morning, Miss Kelsey.
Good morning.
Did you get to feeling better about the graphing after we worked through a few problems together?
Yes, definitely.
Yeah, I thought you were catching on really well. Don't forget the coefficient does affect the graph. Sometimes you didn't change the amplitude, or with secant and cosecant, you didn't change where the turning around point was because of the leading coefficient.
Mm-hmm.
And then I remember that first problem was just you didn't have your tick marks labeled consistently.
Yeah. Thank you.
Yeah, I think you got it. Well, this is showing 3 participants, but apparently I am 2 of them. I am me, and I am the host. So it is you and me. Miss Carly was here and she disappeared. She'll probably come back in just a jiffy. Well, I'm ready to get started. So we'll have a class for 2 if necessary. Hey, the test is Thursday, and I'm going to set it to open at 8:30 to 10. I don't think I'll have a separate practice test other than the one that is on paper in Momentum, or I mailed you a copy of it. So do that, and then the problems that I put on the test will be very, very similar to that. I'm not going to pull anything unusual and sneaky there. One thing to remember about the homework as you're doing it, I have set the question help options to be available in review mode. So if you miss a problem on your first attempt, make sure you go to Gradebook and click review. And then up in the right hand corner, there will be the question tools, and you can do help me solve this. Use that before you use Ask Instructor. Look at the help me solve this. It breaks it down into baby steps for you. And if you still need help, then click the Ask Instructor and I'll be glad to help you with it. Section 5.7 is applications. And these are all pretty straightforward. Actually, the first 16 problems are just solving a right triangle. I give you 2 pieces of information about a right triangle, and then you find all the other information. So let's talk about the labeling of right triangles for a second. If we have any right triangle, of course it has a right angle in it, and the angle opposite the right angle is called the what?
The one that's opposite of the right angle?
Yep.
Hypotenuse.
That's the hypotenuse. All right. So let's just agree to call the hypotenuse C. It doesn't matter which leg you call A and which leg you call B. That's not important at all. It is important that you label them so that we can consistently label our other 2 acute angles. Whichever leg we let B, let the angle opposite it be beta. And whichever angle we let be A, let the angle opposite it be alpha. So once you've chosen which leg is A, everything else about the triangle is set. Now, like I said, in 1 through 16, they give us 2 of these 5 things, A, B, C, alpha, and beta. They give us 2 of them, and we find the missing 3. So 1 through 8 say find the exact value of the missing parts, and then 9 through 16 say give a decimal approximation. So let's look at number 2 first. What we're given there is that beta is 45 degrees and B is 35. That means we want to find A and alpha and C. Now, it helps me to draw my triangle, and all of my triangles look the same. They're not to scale at all. They basically all look like this. But if we label one of the two legs 35, then we have to label the angle opposite that 35 to be our 45-degree angle. And that means the leg we're missing is A, and the angle we're missing is alpha, and we need to find the hypotenuse, and it's C. All right. If we want to find alpha first, how could we find it?
Can't you just say 90 plus 45 and then subtract that by 180?
Yeah, either you can say the sum of all three angles has to add up to 180, or since you know this one's a right angle, you could say these two have to add up to 90. So either one of those things that will work, but alpha is 90 minus 45, which means alpha is a 45-degree angle also. And actually, that tells us automatically what A is. How does that automatically tell us what A is?
It's going to be the same as B
Because why?
because they have the same angle.
Yeah, this is an isosceles right triangle. If these two angles are the same, the sides opposite them have to be the same. So A is 35 also. And the only other thing we need is C. What tool could we use to find C?
Pythagorean theorem.
Yep. C is going to be the square root of leg square plus leg square. And this is, you could just punch that on the calculator. This is a cool way to solve that without a calculator. You can say 35 squared plus 35 squared is 2 times 35 squared. It's just like one ugly plus one ugly is two uglies. And then you can take the square root of the 35 squared and just leave the 2 under the radical. But we were told to give the exact answer here, so that's what we've done. All right, number 6 also says find the exact answer. And here we're given A is 4 square root of 3 and C is 8. In number 45, we were given one of the angles. In number, did I say 45? I'm looking at that 45. Also, I'm looking at my phone. I'm getting a text from Carly that she can't get in. Let me think why she wouldn't be able to get in. Just a jiffy. What would be the easiest thing for us to find first?
B.
Yep, because we're given A and C, so B would be the square root of hypotenuse squared minus leg squared. What's 4 square root of 3 squared? Evan, what do you think 4 square root of 3 squared is?
That would just be 12. 4 squared. Did you hear me?
No, I didn't.
Oh, I thought I unmuted. I said 12, I think.
You forgot to square the 4. You squared the square root of 3, but you didn't square the 4.
Okay, I misunderstood you then. Oh, yeah. I see what you mean now.
Okay. Four squared is 16, and then 16 times 3 is 48. And 16 minus 4, or 64 minus 48, is that just 16? And so B is just 4. Now what would be easiest to find? You know what? That is not supposed to be little b there. That's supposed to be the angle opposite A is alpha. And that's so tiny it's hard to read. That's beta. Which do you think it would be easiest to find next, the alpha or the beta? Or maybe it's a toss-up.
Wouldn't it just be like a toss-up?
Okay, well, which angle would you like to find first if it's a toss-up?
Alpha.
Okay, what trigonometric function of alpha could you use and involve? Let's use the 4 and the 8, not the 4 square root of 3, just because it's easier. If we want to find alpha using B and C, what trigonometric function of alpha would involve B and C?
Would it be cosine?
Let's see. Cosine of alpha would be adjacent over hypotenuse. Yes. Cosine of alpha would be adjacent over hypotenuse. 4 over 8 is a half. Now, if the directions didn't say find the exact answer, then what button could I use on my calculator to find the angle whose cosine is a half? What function on my calculator gives me the angle whose cosine is a half? Anybody? Miss Carly, can you tell me? Oh, she disappeared again. Evan, how do I find If the directions didn't say find the exact answer, what button on my calculator gives me the angle whose cosine is a half?
Cosine inverse.
Yeah, inverse cosine. That would give me a decimal approximation. If I want the exact answer, I can say the angle whose cosine is a half and think about the first quadrant angle whose sine is a half. Would that have to be a multiple of 30 degrees or a multiple of 45 degrees if cosine's a half? Is it multiples of 35 or multiples of, excuse me, I'm sorry. Is it multiples of 30 degrees or multiples of 45 degrees where the x coordinate is a half? Will, can you help me with that?
I'm trying to get caught up right now. Trying to see where everything's at. By the way, did you get my homework?
I did. I have homework from all 4 of you, and I haven't graded it yet, but that's what I'm going to do after class. So you'll see that score appear in your my math lab shortly
Right.
after I finish Zooming today. Okay, nobody's answering me, so I'm going to answer it myself. If we're looking for the angle whose cosine is a half, that's the angle whose x coordinate is a half. That is close to the y-axis. Ooh, play like that's a straight line. Close to the y-axis where x is a half and y is square root of 3 over 2. So that's a 60-degree angle for the angle whose cosine is a half. Alpha is 60 degrees, and that tells us pretty easily what beta has to be. Oops. If alpha is 60 degrees, then beta has to be 30 degrees. All right, so we solved 2 right triangles and found exact answers. One, we were given a side and an angle. One, we were given 2 sides. Now we have some that just say find a decimal approximation. Number 10. Let me get all readjusted here. Number 10 gives us an angle beta that is 64 degrees, 20 minutes, and a side A, which is 20.1. And we don't know what the units are on that 20.1. It's very helpful to me to draw the triangle. If you don't need to, that's okay. There's my side A, my side B, my side C. The way I have it labeled is the 64 degrees, 20 minutes, this top angle or this bottom angle.
It'd be the bottom.
It has, okay, you missed this very, like, first minute of the Zoom wheel, but beta has to be the angle opposite B, and alpha has to be the angle opposite A. So this is alpha, and this is my 64 degrees, 20 minutes.
Okay.
So the 2 things I'm given are A and beta. Which one of my 3 missing things would it be easiest to find first?
Oh, alpha.
Yeah, because alpha and beta together have to give me 90 degrees. So alpha is 90 degrees minus 64 degrees and 20 minutes, which is 2540, I think. 89, 90, yep, 25 degrees, 40 minutes. Now, what could I use to find B? What trigonometric function of the angle that I was given would involve the opposite side and the adjacent side?
Tangent.
Yeah, tangent. So I could say the tangent of 64 degrees, 20 minutes is opposite over adjacent, B over 20.1. And then just clear out my fractions and grab a calculator. B is 20.1, tangent of 64 degrees, 20 minutes. And I thought I had that written down, but I don't. Let me grab my calculator. We're not told what to round to, but I'm getting approximately 41.8. Is anybody else getting that?
Yes.
Okay. Actually, I forgot how to punch minutes on my calculator for just a minute. I remembered now, but I didn't remember when I was punching it. So what fraction of a minute would, or excuse me, what fraction of a degree would 20 minutes be?
That's what I was just about to ask.
How many minutes are in a degree?
60.
All right. So what fraction of a degree is 20 minutes?
Be 1/3.
Yeah. So when I forgot how to punch minutes on my calculator for a minute, I entered 64.33333, as many threes as my calculator would take, and then press tangent. Now, Kelsey, you said you got the same thing without approximating that as 0.3333 degrees. I actually got 41.6. Did you get 41.6 or 41.8?
I got 41.82697.
Okay, maybe I punched it wrong the second time. 64.20 degrees. degrees, minutes, second to decimal degree. Oh, I did punch it wrong the first time, or the second time. Yes, that's what I got. Exactly what you said, 41.827-ish. All right, now we still need to find C, and if we're not working for NASA, we could use the Pythagorean theorem to find C. We have a decimal approximation of C, or excuse me, B, so we could use the Pythagorean theorem to find C. However, if one of us does end up working for NASA, you never use a value that you have approximated to find another value, because you already have a rounding error here. That's not exactly 41.8. And if we are trying to land a rover on another planet, then we don't need to be using decimal approximations here. So if I did not want to use the value that I already have, how can I use, I'm sorry, dang, I stutter a lot. If I don't want to use a value that I've approximated, what trig function of 64 degrees 20 minutes could I use to find C, given only the value that I was given, not the one that I rounded?
So you use sine?
Sine is opposite over hypotenuse. So if I use that, I'd have to use the 41.8 that I rounded.
So cosine.
I could use cosine and not have to use a value that I've rounded. So cosine of 64 degrees 20 minutes would be adjacent over hypotenuse. So hypotenuse would be 20.1 divided by the cosine of 64 degrees 20 minutes. That gives me 89.2. Because of my rounding, those don't add up to be exactly 90, but double check this one. Anybody else get this?
I did.
Okay, I'm punching it one more time myself. Cosine of that, and then times 20.1. Yep, that's what I got. So if we had kept more decimal places, that would have come up closer to 90 degrees, but based on what we rounded here and what we rounded here, it only comes up to 89.2 degrees. No, that was stupid. That was stupid. Why do these not have to add up to 90 degrees? It was bothering me that it was that far off. Why do they not have to add up to 90 degrees?
Because they're just lengths.
Yeah, they're not angles. Our angles are alpha and beta. This and this, they add up to 90 degrees, not the sides of a triangle. Gee whiz, I may not even post this soon. Let's do one more. Number 16. Once again, we're given two legs, or a leg and a hypotenuse. We're trying to find B, alpha, and beta. And we're only going to use what we were given, not some rounded value that we come up with. All right, what do you think it'd be easiest to find first? Miss Carty, were you able to get back in?
Yeah, I'm here. I don't know if you can hear me.
I can, just barely, but I can.
Okay, good.
So what would you like to find first, based on what we're given? Technically, it doesn't matter, but one of the things you could have found in Algebra 1 in high school before you ever saw trig, what could you find without using trig?
I'd like to find B.
Okay, because that would only take the Pythagorean theorem.
Yeah.
It's the missing side of a right triangle. So B would be the square root of hypotenuse squared minus leg squared. I'm getting about 0.53. Does anybody second that? Is anybody getting the same thing?
I am.
Okay.
I am too.
Okay. All right. Hey, one thing I didn't say earlier, good practice is you round your answer to the same degree of precision as the information you were given. So since A and C were given to me to the nearest hundredth, I rounded B to the nearest hundredth. In number 10, we didn't really have to do that because, well, actually, no, we were given A to the nearest 10th, so we rounded B to the nearest 10th and C to the nearest 10th. On number 16, I don't know what to round my angles to because I'm not given a different angle. I'll probably round it to the nearest 10th of a decimal degree. All right. What trigonometric function of alpha could we use to find alpha without using this value that we've rounded? Which trig function of alpha would only use the A and the C?
Would it be cosine?
If we're trying to find alpha, is A the opposite or adjacent?
Oh, I thought you said beta. I'm sorry.
Oh, that's okay. That's okay. If we're, and it doesn't matter which one we find first, but if we want to find, well, let's do what Kelsey suggested. If we want to find beta first, we could use cosine beta is adjacent over hypotenuse, 0.42 over 0.68. And I certainly could leave that decimal as 0.42 over 0.68. My brain almost automatically multiplies it by 100 over 100 to clear out the decimals, and then reduces it by 2 to 21 over 34. But you don't have to do that. I can't squint hard enough to tell you where on the unit circle there's an angle whose cosine, which means whose x coordinate, is 21 over 34. So how am I going to find beta if I can't squint hard enough to figure it out? Evan, I think you said it a minute ago. What function on the calculator gives me the angle whose cosine is 21 over 34?
Inverse cosine.
Inverse cosine. So I'm going to enter on the calculator, beta is inverse cosine of 21/34. And if I want my calculator to give me degrees, then I need to make sure my calculator is in degree mode. I do want my calculator to give me degrees because this right triangle, that angle is measured in 90 degrees. I got about 51.8 degrees. Now, if we're not working for NASA, we can say if this angle is 51.8 degrees, this angle would have to be 48.2 degrees so that they would add to 90 degrees. But if we are working for NASA and we don't want to use a value we have rounded, how else could we find alpha?
Can you repeat that one more time?
If we don't want to use this value that I've rounded, how can we find alpha using only these two pieces of information that we were given, not one that we approximated? Miss Carly, which trig function of alpha would involve A and C? We were about to take a test. Well, actually, we are about ready to take a test. Test is Thursday. A is opposite alpha and C is hypotenuse. So the sine of alpha equals opposite over hypotenuse. And that means alpha is inverse sine of 21 over 34. These two angles, alpha and beta, are supposed to add up to 90 degrees. Because of our rounding, they only add up to 99 or to 89.9, but that's still very close. If we had kept more decimal places, those would have added up to exactly 90 degrees. All right, we have time, let me see. We have time to do just a couple of examples. we have 2 days to do 5.7. I've gone ahead and assigned both days homework, where I may not have clicked assign on day 2 homework. I definitely have assigned day 1 homework. Most of them are just solving right triangles, but let's do one that says either angle of elevation or angle of depression. Let me find one that says that real quickly, because there's one in the homework. Number 26. There's something I need to tell you about angle of elevation or angle of depression. When you see angle of elevation or angle of depression, that's always, always, always with respect to the horizontal. Now, in this section or these word problems, if you get your triangle labeled correctly, you're going to get the right answer. The hard part's drawing the picture. Don't look at the picture in the book, because on the test, I'm not going to give you the picture. Drawing it is the hard part usually. So number 26 says, from a point 15 meters above level ground is one of the 2 things I can draw. And then I can draw a point and say that point is 15 meters above level ground. From a point 15 meters above level ground, a surveyor measures the angle of depression of an object on the ground at 68 degrees. Is the surveyor on the ground or on top of this hill or something? Where's the surveyor?
He's up on like some kind of hill or something.
Yeah, it says from this point, 15 meters above level ground, the surveyor, that's my very best surveyor, measures the angle of depression. I'm not sure what to do with that yet, but I can draw my very best object on the ground. And then I know, because of this note, angle of depression is always with respect to the horizontal. If I draw this line from the surveyor to the object of the ground, on the ground, this has to be my 68 degrees, because angle of depression is always, always, always with respect to the horizontal. Some folks put the 68 degrees up here because that's where the surveyor is. That won't give you the right answer. All right, the question is, how far is the object, here's the object, from a point on the ground directly beneath the surveyor? So we're looking for this distance. You can let it be X. I'm going to let it be D, doesn't matter. Which trigonometric function of 68 degrees could I use to find D?
Tangent.
Tangent.
15's the opposite side, D's the adjacent side. So it's tangent of 68 degrees. That would equal opposite over adjacent. And D would be 15 divided by the tangent of 68 degrees. I do have that answer written down from a previous lifetime. I got about 6.1. And since this distance was measured in meters, that's 6.1 meters. Pretty easy?
Yeah.
Yep. Let's do one more. And then you can try that day one homework. Again, it is mostly just solving a triangle. I think it has a couple of the angle of elevation or angle of depression problems. So let's do 28 and call it a day. 28 says a guy wire is attached to the top of a radio antenna and to a point on horizontal ground. You know what a guy wire is?
Not a clue.
Have you ever lived somewhere that had a utility pole in the yard?
Yep.
The guy wire is the wire that will decapitate you if you're mowing around the utility pole and you don't duck.
Oh.
Oh yeah. That's what a guy wire is. So this is my utility pole. This is my guy wire attached to the top of the pole and a point on the ground to support that pole. And a guy wire is attached to the top of an antenna and to a point on the horizontal ground that is 40 meters from the base of the antenna. Here's my base of the antenna. So it's giving me this distance is 40 meters. If the wire makes an angle of 58 degrees 20 minutes with the ground, or the directions could say if the guy wire makes an angle of elevation, if the guy wire's angle of elevation is 58 degrees 20 minutes, then again, angle of elevation would mean with respect to the ground or with respect to the horizontal. Approximate the length of the wire. Looks like the hypotenuse. So what trig function of 58 degrees 20 minutes would involve the thing I'm given and the thing I'm looking for?
Would it be cosine?
Yep. Cosine of 58 degrees 20 minutes is adjacent over hypotenuse. And from some other lifetime, I have that answer as 76.2. This was given to us in meters, so that 76.2 is meters. All right, do you have any questions?
Nope.
These are some of the easiest word problems you've ever solved. If you're practicing some problems in the book, you should be able to do I'm gonna say for tonight, do 1 through 15 and 25 to 31. And then we'll pick up with 32 tomorrow. And you have 6 problems in my math lab. Alrighty, y'all have a good day. See
You
you
too.
tomorrow.
Bye.
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 Thank you.